In this video, I will walk you through the 5 steps you can take to solve number series questions on your test. The first step in any number series question is always going to be finding the difference between each pair of numbers or subtracting each number from the next number. By finding these differences, we can quickly identify the most common type of pattern, which is arithmetic pattern. So if we find these differences here, the difference between 22 and 19 is minus 3, 19 and 16 is minus 3, and 16 and 13 is also minus 3. So we have an arithmetic pattern of subtracting 3 between each number, and so we can apply that pattern to 13 to find 13 minus 3, which is 10, the next number in our series. Let's try an example that doesn't have an arithmetic pattern. Let's say we applied step 1 to this example here. We would have, taking this difference, we would have a difference of plus 1.5, then a difference of plus 6, and then plus 24. There is no discernible pattern between these additions, so we need to try something else. We need to move on to step 2 of our test question strategies, which is looking for geometric changes. So looking for patterns that involve either multiplication or division. So if we instead look at this as what could we be multiplying to 0.5 or dividing 0.5 by, and the answer is we're multiplying this by 4. 4 times 0.5, or 4 times 1/2, its fraction equivalent, is going to give us 2. 2 times another 4 will give us 8, and 8 times 4 will give us 32. So now we have a consistent pattern of multiplying every number in the series by 4, which means we can apply that to the last number in our series. 32 times 4 will give us 128, the next number in our series. Let's say you have another example that doesn't follow an arithmetic or a geometric pattern. What would you do then? Let's take a look at our third example here. If we were to find the difference between each pair of numbers following step 1, then what we would do is find the difference here, which is plus 1, here, which is plus 2, plus 3, and plus 4. Because these are not all the same differences or additions, we cannot say it's an arithmetic pattern. And there's no multiplication or division happening here, so there's no geometric pattern. But what we can do now as a part of step 3 is find the differences between these differences. So what's the change from plus 1 to plus 2? Well, that's plus 1. What's the difference from 2 to 3? Well, that is also going to be plus 1. And here I'll do it inside the arc so it's a bit easier to see. Plus 1, and between 3 and 4 is another plus 1. So now we see a consistent pattern. This is a gradual change pattern where we are gradually changing the number that we are adding or subtracting to this number series. So if we want to find the difference, this last difference here, we need to take 4 and add 1, which will give us plus 5 in this slot. So now to find the next number in our series, we take 10, add 5, and we get 15 as the next number in our series. Let's do another example. In this example, if we were to find our differences between each pair of numbers, we would have a difference of minus 40, a difference of minus 20, and then a difference of minus 10. There is no arithmetic pattern going on here and no geometric pattern. So let's find the differences between our differences by using step 3 of our test-taking strategies. If we find the difference between 40 and 20, we'll see that we are dividing 40 by 2. And 20 divided by 2 will also give us 10. We are gradually changing the difference applied to each number in our number series by dividing the difference by 2. So if we want to find the next difference, we would need to divide by 2 again. 10 divided by 2 would give us 5. So we're going to subtract 5 to find our next number in the series. 30 minus 5 will give us 25, the next number in our series. If you work through steps 1 through 3 and you are still stuck, you are still unable to find the correct answer, then we move on to step 4 where we start considering the possibility of alternating or combined patterns. Typically, this involves either arithmetic or geometric being combined with a gradual pattern. And those can look like this. If we have an arithmetic plus a gradual, we might see +2, then -6, +2 again, -4, +2 again, and -2. So the addition part, the arithmetic part, is +2 every other difference. And then the gradual part is going to be this -6. That difference is lessened by 2 to -4, and that difference is lessened by 2 again to be -2. The same thing is true of an alternating pattern between a geometric and a gradual. So if we have geometric and gradual, that might look like multiplying by 2, then adding 3. Multiplying by 2 again, there's that geometric piece that's repeating. And then we add 6, we've increased the difference by 3. Then we multiply by 2 again, and we increase that difference one more time to get +9. Then the last example, you can have two different alternating gradual changes going on at the same time. So it would be a gradual plus another gradual. So let's see what that would look like. We could have +2, -2, +4, -3, +8, -4. So the subtraction pattern is gradually decreasing by 1 each time, while the addition is gradually increasing by a multiple, not an addition, by a multiple of 2. 2 times 2 is 4. 4 times 2 is 8, and so on. So now let's look through these 4 examples for some combined patterns. In example 1, the difference between 5 and 2 is -3. The difference between 2 and 4 is going to be +2. Then we have -3 again, +1, and then -3. So we do notice one consistent pattern. We have -3 every other time. So that's an indicator that we have a combined pattern. So something is going on here. It's not quite addition, or if it is a gradual change of addition. Let's see if it might be geometric in nature. What times 2 would give us 4? Well, that would be 2 times 2. And then over here, what times 1 would give us 2? That would also be times 2. So we figured out the combination. It is a geometric and an arithmetic pattern. So if we want to find the next number in this series, we subtracted 3. So the next step would be alternating back to multiplying by 2. -1 times 2 would give us a -2, making that the next number in our series. Let's look at example 2. Example 2, if we find the difference, we're adding 2, adding 2, adding 2. So far, it looks like we have an arithmetic pattern, but then all of a sudden it changes. And now we have +3. Then we go back to another +2. And then all of a sudden we have +4. So what is going on here? It seems like we might be alternating between an arithmetic pattern of +2 every other time and a gradual change pattern, 2 + 3 + 4. So we're increasing the difference by +1 each time. So to find the next number in our series, we have the gradual change, and I'll actually change colors for this. The gradual change one is +2, +3, +4, and then our arithmetic pattern is just +2 every single time. So if we ended on our gradual change, then we are going to go back to our arithmetic pattern, our +2. So we need to have 17 + 2, which would give us 19, the next number in that series. For examples 1 and 2, we showed combined patterns that were alternating back and forth between each other in a pretty predictable pattern. But for examples 3 and 4, it's not alternating back and forth. There are still two patterns going on, but it's almost as if there are two different strands that are present within the number series. I'll show you what I mean. If we look at all of the odd positions, so every other number in the series starting with 3, we'd have 3, 5, 7, and our unknown next number in the series. If we just find the differences between these numbers, we will find our pattern. So we have the difference between 3 and 5 is +2, the difference between 5 and 7 is +2, and the difference between 7 and our mystery number would also be +2. So then our mystery number in that case would be 7 + 2, which is 9. With the other strand, our even position numbers, or every other number starting from 6, and I'll even add another mystery number over here just for teaching purposes. The difference between 6 and 10 would be +4. The difference between 10 and 14 is +4. And the difference between 14 and our mystery number would be another +4, thus making the next number in our series 14 + 4, which would be 18. In this case, it's almost like there are two completely separate numeric series going on, just interwoven between each other. Let's do another example. In example 4, we'll follow the same pattern of looking at every other number starting from the first number, going on to a second mystery number out here for learning purposes. And then we will check every other number starting from our second number. So let's do that first. So 2 to 4, 4 to 8, and 4 to our mystery number. This looks like it might be a geometric pattern of times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 would give us 16, making that our mystery number. Then if we go back to our other strand, we have 1 to 2, 2 to 3, and 3 to 4, which looks like just a difference of +1 each time. So our extra mystery number for learning purposes would be 4 + 1, which would give us 5, making 16 and 5 the next two numbers in our series. If you have gone through steps 1 through 4 of our test-taking strategies and you are still stuck and unable to find the answer, then it's time to consider our most rare number sequences, or our special cases. These are numbers that follow our exponent patterns, like square numbers or cubed numbers, that follow prime number patterns, or follow the Fibonacci sequence. So let's take a look at example 1. If we look at example 1, the differences between each of these numbers don't follow a discernible pattern. We have +3, then +4, then all of a sudden it's up to +7. And there's no geometric sequence either, nor is there an alternating pattern. So we have to go to step 5 and think about, could this be a square, cubed, prime, or Fibonacci? And the answer is that it is a square pattern. We have 1 squared is equal to 1, 2 squared, which is equal to 4, 3 squared, which is equal to 9, and 4 squared, which is equal to 16. Then the next number in our series would be 5 squared, which would give us 25. For example 2, again, the differences do not follow an arithmetic, geometric, gradual change, or an alternating combined pattern. But what it does follow is the Fibonacci sequence, because each number starting after the first two numbers is made up of the sum of the previous two numbers. So if we take a look at 5 and 3, if we were to add these two together, we would get 8 as our next number. Then if we add 5 and 8 together, we get 13 as the next number in our series. If we add 8 and 13, that sum will give us 21, the next number in our series. So to find the missing number in our series, we must add together the previous two numbers in the series. So 13 plus 21 will give us 34, the missing number in our series. Our final tip for this video is to try and solve these number series questions without looking at the answers first. If you glance at the answer options too soon, you may waste time trying to fit a pattern to each choice rather than identifying the actual rule. So work out the solution first. Once you have a guess, you can check the options. If your answer appears, you've likely found the right logic and saved time second-guessing yourself. But if you cannot find the correct answer, that's always a clue for you to go back and retry the sequence and maybe try looking for other patterns of logic by using the other steps mentioned earlier in this video. There are, however, some instances where it may help to look at the answers if you are really, really stuck. If you can't identify a clear pattern, like with this example, we have a difference of +2, then -6, +2, -4, and then +2. You can identify here that there is two alternating patterns. We have +2, and then we have a gradual change. -6, decrease that by 2, -4. So we would likely decrease it by 2 again here, right? And that would give us the answer choice 4. But let's say our answer options are A, B, C, and D, and our answer choices are 3, 5, 6, and 8. This is an instance where if you look at your answer choice, you can see that 4 is not an option, so we need to reevaluate. What if instead of subtracting in every other number, we are maybe instead dividing? Maybe this could be geometric. Let's try dividing 12 by 2. We would get 6. Then we would add 2. If we divide 8 by 2, we would get 4. Then we would add 2. This is a much more consistent pattern. So then here we would need to divide 6 by 2 in order to get our answer. And if we bring those answer choices back up, we would find that, we would find that 3 is among those options, even though 4 was not. And now we can find our correct answer. In summary, number series problems are all about pattern recognition. By following these 5 streamlined steps and using the answer choices wisely, you'll solve most sequence questions faster and more accurately. With practice, you'll recognize common patterns and become much quicker at spotting the solution. And no matter what, if you exhaust all of these steps and you are still stuck on your question, skip it and return to it later, because sometimes the solution is more obvious with fresh eyes. Good luck, and we'll see you in the next one.